All right, math counts. Here we go. We've got warm up one. This is from the 2017 problem set since we don't have our current problem sets done yet. So what we're going to do is I'm going to go through the problems. I would encourage you to try them out yourself first and then look at my solutions. So I'll kind of pause before I do each of the solutions. All right, so here we go. Warm up one, problem one from the 2017 solution set. Or problem set, sorry, not solution set. Here we go. So this one says a time capsule was sealed in 1940 and will be opened on the same date in 2017. How long will it be remain sealed? Well, we need 60 years to get up to the year 2000. And then we would need 17 years after that. So it looks like we're going to have 77 years. So some of these problems you'll find as you go through this are super easy. So speed and accuracy are the most important things to focus on for here. So if you've got an easy problem, don't sweat it. Just work on your speed and your accuracy. Next one's a nice proportion problem. It says the length of five small paper clips is equal to the length of 2 large paper clips. The length of 8 small paper clips is equivalent to the length of how many large paper clips? Oh my gosh. Express your answer as a mixed numeral. Okay, so really pay attention when it gives you instructions like this, how they want your answer. Because if you leave it as an improper fraction, they're going to mark it wrong. Your problem has to be exactly correct in math counts to work. So this is a really good proportion problem. I would maybe compare the small paper clips to the large ones. Again, if you have not done these problems yet and you are just kind of lurking around looking at it, you would pause before I start each of my solutions. Anyway, here we go. The length of 5 small. So 5 small is the same as 8 large. Okay, now I'm going to write a proportion. No, too large. What am I doing? All right. So 5 small is too large. And now we want to know the length of 8 small. So small I put in the numerator is equivalent to how many large? I don't know. So now I'm going to solve it as a proportion. I get 5x. I do using cross products here. 5x equals 2 times 8. Divide by 5, and I get 16 fifths. But it wants it as a mixed numeral. So 5 goes into 16 3 times with 1/5 left over. So we have 3 1/5 for this one. All right, next one. In the figure shown, if no cell may be visited more than once, and not every cell must be visited, how many paths start in cell 1 and end in cell 7? Okay, so we have to get from 1 to 7. We can take any path, but we can't double visit any cells, and we don't have to go to every cell too. Well, the most direct path is pretty obvious. I can just go from 1 to 7. So if I want to go from 1 to 7, there's one way to do that. If I start at 1 and go to 2, I could go 1, 2, 7. That's one way to do it. Or I can go 1, 2, and then go all the way around to get back to 7. So if I go from 1 and then go to 2 to 7, there's 2 ways to do that. I can go 1, 2, 7, 1, 2, 3, 4, 5, 6, 7. So there's 2 ways to do that. And actually, every other one is going to give us 2 ways to do that, because I can go 1 to 3, then to 7, 1 to 3, and then back the other way to 7. So 1 to 7 is one way. And then I've got 1, 2, 3, 4, 5 directions I could go where there's 2 for each of those. So I've got 1 to 7 is one way, and then there are 5 ways to do it, or 5 directions to go where you would get 2 ways. So I've got 10 of those. I can go here, 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 and then I got one of these. So it's 10 plus one way. We would get 11 ways to do it. hope that made sense. That didn't really make sense to me when I was just saying it, but whatever. All right, next one. What is the value of 4 divided by 2/3 minus 5? Okay, so we're going to go ahead and change this into 4 times 3/2. Using the order of operations, we should do division before subtraction. For this, you can multiply going straight across. I like to reduce first. 2 goes into 4 twice. I now have 2 times 3 in the numerator. So I've got 6. And then 6 minus 5 is 1. So I did that whole, I think in like 6th grade, they call it keep change flip or whatever. So I went ahead and did that, got 6, and subtracted 5 and got 1. Next, what is the absolute difference between 1/2 and 1/3? Well, it would be really nice to have a common denominator so I can check the difference between them. So the common denominator would be 6. So 1/2 is 3/6, and 1/3 is 2/6. So now that they have the same denominator, it looks like the difference between them is 1/6. So there's my answer. Next, number 6. All right, this is a really good Pythagorean theorem problem on this one. So if you haven't done the Pythagorean theorem or Pythagorean triples or whatever, you should probably watch the video on how to do the Pythagorean theorem. I think on the 2 solution or the problem sets that I'm giving you today, you're going to have a couple problems where you need to do the Pythagorean theorem. So go ahead and watch those videos on the Pythagorean theorem if you want to. So this one says the perimeter is 34 and AB is 5, and this is a rectangle. Well, in a rectangle, I know that these 2 sides are the same. I also know that these are right angles. Okay, so I've got 10 so far, and the total perimeter is 34, so that means I have 24 left over for the perimeter. So that means this has to be 12, and this has to be 12. And now I've got the full perimeter is 34. Okay, so I want ABD. I want this triangle over here. I want the perimeter of it. I know that this side is 5. I know that this side is 12. I need to find out what this diagonal is. So I need to either use the Pythagorean theorem, or if you know your Pythagorean triples, you will know that this is automatically 13 because 5, 12, 13 is one of our Pythagorean triples. Again, if you don't know what a triple is, I would go watch the video on Pythagorean theorem and the triples. Now, if you decided to use the Pythagorean theorem, it would have looked something like this. You would have said, oh, 5 squared plus 12 squared equals that diagonal squared. 5 squared is 25. 12 squared is 144. Those add up to 169. And then to undo squaring, you would do the square root. So the diagonal would be the square root of 169, which just so happens to be a perfect square. The square root of 169 is 13. So now I know that this is 13, either by my triple rules or by the Pythagorean theorem. So 5 plus 12 plus 13. Well, 13 plus 12 is 25. 25 plus 5 is 30. So we get a perimeter of 30 there. Next one. Harvey has a fair 8-sided die that has different number from 1 to 8 on each side. Okay, so he's got an 8-sided die. He rolls it twice. What is the probability that the second number rolled is greater than or equal to the first number? All right, so the first thing that we have to do is find out how many possible outcomes are there from rolling 2 8-sided dice. Well, there are 8 ways for the first roll to happen. And then the second roll also has 8 ways. So there are 64 different possible outcomes for this event. Where I roll 1 die, there's 8 ways to do that. And I roll the second die, there's 8 ways to do that. That means we have a total of 64 ways to roll those 2 dice. This is my denominator. This is how many potential outcomes I could get. Now I need to find out what my numerator for this would be. I'm looking for where the first number rolled is greater than, no, The second number rolled is greater than or equal to the first number. Okay, so let's just kind of think through this and we'll see a pattern emerging here. If I roll a 1 first, then it doesn't matter what happens on the second die because it can be greater than or equal to. So I could roll a 1, I could roll a 2, I could roll a 3, 4, 5, 6, 7, 8. I've got 8 different outcomes if I rolled a 1. If I rolled a 2 first, well then I can't roll a 1, but I could roll a 2, a 3, a 4, a 5, a 6, a 7, or an 8. So there's 7 outcomes if I roll a 2. If I roll a 3, I could roll a 3, a 4, a 5, a 6, a 7, or an 8. That's 6 outcomes. If the first roll is a 4, you see the pattern emerging here? If it's a 4, I could do a 4, 5, 6, 7, or 8. That's 5 outcomes. If I roll a 5, I can roll a 5, 6, 7, or 8. That's 4 outcomes. If I roll a 6, 3 outcomes. 7, 2 outcomes. If I roll an 8, the only way for this to work is for me to roll an 8 on the second one. So I have all of these possible outcomes, so I just need to add up all the numbers from 8 to 1. And if you add 8 through 1, you get 36. So there are 36 outcomes where I am greater than or equal to the first number out of a total possible outcomes of 64. Now this does say express it as a common fraction. So I need to reduce this. So what's the largest number that goes into 36 and 64? That would be 4. 4 goes into 36 9 times. It goes into 64 16 times. So the probability the second one is greater than or equal to the first one would be 9/16. Next, in scientific notation, what is the product of 1.2 times 10 to the third and 1.4 times 10 to the second? Express your answer to 2 significant figures. All right, so I got 1.2 times 10 to the third. I'm going to multiply that by 1.4 times 10 to the second. So 1.2, make sure you're pausing if you're doing this from home. 1.2 times 1.4 ends up being 1.68. And then remember our exponent rules. If we have exponents and we're multiplying, we should add them. So this is times 10 to the fifth. Now, if we wrote this down as our answer, we would be wrong because it said to 2 significant figures. That means I can only have 2 digits right here. So I need to round this one up to 1.7 times 10 to the fifth. Next, when the integer n is squared, the result is less than 150. What is the sum of all possible values of n? And this one is a problem where if you don't think through the problem, you're going to get the wrong answer. Because the first thing you thought of is, okay, the biggest perfect square is 144. So 12 squared would be 144. So 12 squared works, 10 squared works, 11 squared works, 9 squared works, 8 squared works. And you go, okay, it's all the numbers from 1 to 12. I'm going to just add up all those numbers. But you have to remember, there is more than one way to square a number and get 144, because you can also square negative 12 and get 144. When it says integers, remember integers can be both positive and negative. So the 12 squared where you get 144 is going to cancel out the negative 12 squared where you get 144. 11 squared where you get 121 is going to cancel out negative 11 squared where you also get 121. So every single pair is going to cancel out the other one. 9 squared is going to cancel out negative 9 squared. 8 squared is going to cancel out negative 8 squared. So the sum of all the values would end up being 0 because all the positives would cancel out the negatives. Last one. Minnie paid a one-time registration fee of $30 for dance lessons. Additionally, she paid $20 per lesson. So her total amount that she paid, she starts with 30, and that's a one-time fee, so it is constant. And then it is $20 per lesson. So $30 plus $20 per lesson. We're going to take 7 lessons. So this is $20 times 7. We've got $30 plus $140. It looks like it's going to be $170 for that one. All right, that's all we got for warm-up 1. Keep mathing hard. I'll see you later. Bye-bye.